Okay, let's do the problem set to gross domestic product and economic growth. And let's start with first question. The price index used to calculate most cost of living adjustments is the... Okay, so here the emphasis is on the cost of living adjustments. But you know we have two price indices. One is the consumer price index, the other one is the GDP deflator. Of course, there are other ones too, but when it comes to the cost of living, we focus on a basket of goods which is held constant over time, except that we change the prices for the constant goods or for the same basket. And it's not the producer price index because that's not really cost of living adjustment, and it is not a GDP deflator because the GDP deflator does not hold constant the basket, and the same would apply to the NDP deflator. So the answer must be A, the consumer price index. So, okay, let's move to 2. The consumer price index is computed by comparing the cost of a typical market basket of goods purchased during a base year evaluated at base year prices with A, the cost of the same market basket evaluated at current prices. Yeah, that is correct. The cost of the current market basket, no, it needs to be the same. The cost of the current also, whatever it is, cannot be right because it must be the same market basket. And the cost of the same market basket evaluated at base year prices, now there wouldn't be any change, there would be always 100 or 1. So again, we calculate the consumer price index in a certain period T as the cost of basket in T over the cost of the basket in the base year B. Okay, so the answer is the cost of the same market basket evaluated at current prices. So T is the current prices. A price index in years after the base year is never 100. No, that would imply that there is always never inflation or deflation. It's always greater than 100. That means there is always inflation, but there could be deflation. It's always less than 100. That would mean there is always deflation. So the correct answers can be greater than, less than, greater than, or equal to 100. Okay, so the CPI increases from 80 to 84. So the rate of inflation is now, okay, so let's say we have the CPI today, that is 84. And yesterday or last year, T minus 1, it was 80. Okay, so there's obviously an increase in the price index. So there was inflation, so how much inflation was there? So we knew the percentage change formula. Which is, simply the new value minus the old value over the old. So in this case, the new one is the 84 minus the 80 over the 80, which is 4 over 80, or 1 over 20, or 0.05. So the answer is 5%. The answer is 5%. And of course, if this is the formula, an alternative formula would be n over O minus 1. So the new over the old minus 1, that would be the same thing. So, because then we would do 84 over 80. So if we do 84 over 80 minus 1, well, it turns out that would be 1.05 minus 1 equals 0.05. Okay. In 1969, the CPI was 37, and then in 99 it was 166. Okay, so again the same thing, CPI in 69 was 37, and then the CPI in 99 was 166. From these figures we can conclude that in the United States prices increased about, I mean, if you just see, that should be roughly more than 3 times, but the formula is again the percentage change formula. So we take the new value, 166, and now I divide by the old, 37 minus 1 equals, so now let me get my calculator here, 166 divided by 37 equals 4.486 minus 1 equals 3.486, which is roughly 300, which is exactly 348%, or roughly 350. So the answer is 350. If the consumer price index, so it's again similar question, if the consumer price index at the end of 1990 was 125, okay, CPI in 90 was 125, and at the end of 2000, so it was 133. So again the percentage change formula would be, now I use again the other one, new minus old. The new is 2000, 133 minus 125 over the old 125. So that is 8 over 125. That's probably 6.4%. So let's double check. 8 over 125. 8 divided by 125, 0.064. And of course, if you still want to multiply times 100 to get it in percent, not 1,000. If you still want to multiply times 100 to get percent, it would be 6.4%. So it's 0.064 times 100 equals roughly 6.4%. Okay, let's move to the next question. Suppose that both real GDP and prices double. We can conclude that nominal output, okay, more than doubled, rose by less than double, or did not increase. Or this can be easily just derived if we know, let's say, we have the real output and we have the price. So let's say we produce in real terms 100 apples. The price is $1. So then the nominal output, or nominal GDP, nominal output is 100 apples times the price of $1 would be 100. Then in T2 everything doubles, so now we produce 200 apples. the price of an apple doubled, so it's 2. So now our nominal output is obviously 400. So that is more than doubling. It's an increase by 300%. Okay, suppose that nominal GDP is 6,000 billion and real GDP is 3,000 billion. What is the GDP price deflator? Okay, so we know that the GDP deflator is defined as nominal GDP, which captures all the inflation, over real GDP, which does not capture, which is all with a reference to the base year prices, so it doesn't capture inflation. So we just plug in the value 6,000 over 3,000, so that is 2. And then if you still want to multiply this times 100, that's 200, or 200%, so 200. Okay, 9. Suppose that nominal GDP is 7,700 and the GDP deflator is 110. Okay, so we know that the GDP deflator is defined as the nominal GDP over real GDP, and then, we like to do 100s. Okay, so now we can plug in the values. What do we have? So we know that the GDP deflator is 110, so we plug in here 110. And the nominal GDP is 7,700. And the question is, what is real GDP times 100? Okay, let's first divide both sides by 100. Then I get 110 over 100, that's 1.1, equals 7,700 over the real GDP. Okay, so now just divide both sides by 1.1 and also 7,700. I multiply both sides by YR and divide by 1.1, and then I get real output equals 7,700 over 1.1, which is 7,000. Okay, so those are just pretty straightforward applications of some formulas. If prices rose by 3% and nominal output rose by 5%, so real output rose. Okay, so we have real output, and so real output is defined as nominal output, just as we had in the previous example, so like nominal GDP over a price index. So, and the price index is could be the GDP deflator or the consumer price index. And you still remember in the previous example, the nominal output was 7,700, and then we divided essentially by 1.1, and we got the real output of 7,000. Okay, so but now if the questions, everything changes. So if nominal output changes and price index changes, how does the real output change? So, and that formula is, so the delta means for change, the change in real output is equal to the change of the nominal output minus the change in the price index. And of course the change in the price index, that is inflation, and the change in nominal output, that is nominal growth. So the change, the real output growth, is equal to the nominal output growth. So that grew at 5%. But the prices rose by 3%, so minus 3%. So the answer is real output must have grown by 2%. Okay. Okay, so now we have a similar problem. In 2000, the nominal interest rate was 7% and the rate of inflation was 2.7%. So the real interest rate was, okay, so now it's a similar problem. So let's say if you invest $1 and something grows at 7%, or yeah, it doesn't matter. So let's say generally you invest $1, and if it grows with interest, the interest is like a flow, but the stock variable is 1 plus the real interest rate. Okay, so this is a stock variable now, where 1 plus R is, you know, your investment plus the real interest rate. Okay, so this is a stock variable, and R is basically the flow, and that is equal, so your investment plus the real interest must be equal to your investment plus the nominal interest. I just call that I, so I is the nominal interest. So now this is your investment plus the nominal interest, and we divide it again by a price index, and the price index is 1 plus, let's call it pi, inflation. So pi is a flow, it's the rate of inflation, but 1 plus pi is a price index. 1 plus I is a flow, it's a flow, and it's the nominal interest, and 1 plus I is a stock, which is your investment plus the nominal interest, and 1 plus R is a flow, is a stock, and R, the real interest rate, is a flow. Okay, so now we can basically apply the same formula. So if you want to look at, if you want to solve for R, and R is a small value, we can actually take this one and say, you know, the rate of change, the real interest rate, is simply I minus P, the rate of inflation. So the real interest rate, is equal to the nominal interest rate minus the rate of inflation. If you use your calculator, you know, you would see that for very small values, this approximation always holds. So technically, if we would solve it mathematically, we would say 1 plus R, so the mathematically correct answer would actually be 1 plus the nominal interest rate, which was 7%, so 0.07. So that is the stock of your investment with the nominal interest divided over the price index, which is 1 plus the rate of inflation. So, and the rate of inflation is 2.7%, so 0.027. And if we do that, then we get on the right hand side 1.07 divided by 1.027. Okay, and then in order to get R, I still need to subtract 1, so R is 1.07 over 1.027 minus 1, and that is roughly 0.042. Okay, so that would be the exact real interest rate, but what we do is we use an approximation, and the approximation is that for small values the real interest rate, which is the change, by how much does something change, a percentage change, the flow, is equal to the nominal interest rate minus the rate of inflation. So now what we would do is R equals I minus pi. R is the real interest rate, I the nominal, pi the rate of inflation. So now we would say that this is 7%, so that's the approximation, minus 2.7%, which is 4.3%. That's very similar to what we got when we did it mathematically exact. But again, for small numbers, the approximation, by just dropping, for small numbers, we just can drop all the ones, and we subtract simply from I the pi, the nominal interest rate, the rate of inflation, and then we get the real interest rate. So the answer is 4.3%. And yeah, okay. So there's another problem, which is like maybe it looks a little bit more comprehensive. So let's just stop here and continue with this problem in the next video.